We have water flowing and it's all coming through this amazing wetland filtration system. What's going on, everybody? The Pond Professor here. I am coming to you today from Aqualand. I just returned from our trip in Africa. The project is looking incredible, and I want to take some time out and talk about the wetland filtration system. This is always that main infrastructure component that is critical for the success of any type of feature that we're actually designing and building, no matter what it's going to be. The picture I have right now on the screen is Aqualand, our corporate headquarters located in St. Charles, Illinois, also known as the water garden capital of the world. Just check out that incredible 600,000 gallon water feature that we have, which is loaded with all types of exotic fish, and it has been operating flawlessly since 2008. I look at every feature individually, but I always like to start philosophically, I guess, to talk about some of the information behind the reason why we're doing it. No different than this feature at Aqualand. I want to make sure our client in Southern Africa has perfect water quality, and there's a lot of unknowns that we actually have happening on this particular project. Number one, it's incredibly hot. Number two, it's incredibly dry.
It's dry. It's really dry.
That is a very tough combination because the relative humidity, because it is low, is going to want to suck water out of the water feature, which is going to mean we're going to have to add water. So we're constantly battling this cycle. In order to compensate for that, if you followed one of the previous vlogs, we installed a 50,000 gallon underground reservoir, which is going to help to feed and to also help to mediate some of that water evaporation. There's a shift in dissolved oxygen that's held in the water. The higher the water temperature, the lower the dissolved oxygen rate that the water can actually hold. And it might not seem important, but when you start getting these things happening, having lower dissolved oxygen, we need to increase the overall circulation to compensate for that. Not only is it because of the fish inside of the feature, but it's the microorganisms. And that's really what I want to talk about here today, is the microorganisms inside of this feature. Because a wetland filter is basically, it's a home. It's a massive condominium complex for microbes. All these little things are going to live inside of this giant underground structure, and we're going to be force feeding them dissolved oxygen as well as food. I'm not worried about the food coming in because there will be food, and by food I mean any type of dissolved organic compound. It's going to be from fish waste, could be windblown debris that comes in, it could be leaf debris that starts to decay inside of the pond, uneaten fish food, you name it. All of those things are organic. We need to break them apart so we can detoxify the water, and that's really what I want to talk about here today. Going back into the 80s, it's not that far, but back into the 80s, the big push into green infrastructure and trying to come up with ways of actually managing stormwater runoff as well as human waste. This system was called a rock reed filter. It was actually designed for rural communities in southern Alabama and southern Mississippi where they didn't have the money and they didn't have the ability to create traditional infrastructure for these smaller communities. What they tried to do was come up with an inexpensive, low-tech solution for managing waste. So what they did was they created a septic field, basically, large septic tank to remove the main solids, but then they have black water. Black water has all the bad bacterias and all the dissolved nutrients, etc., that are inside of the water system. They can't just take that and dump it into a river system. So there's laws that have been put in place. The EPA has a lot of regulations. You cannot just take raw sewage and dump it into a river system or lake system. So what they decided to do was create these rock reed filters, which was basically a wetland filtration system. What they're doing is they're taking this black water and they're dumping it into a rock reed filter, which replicates nature. Basically, it's a gravel layer that is loaded up with different types of reeds. So by passing this water through this long system, and had a gentle slope to it, the water would slowly percolate through all the rock and gravel as well as the root zones of all these different aquatic plants. And by the time the water ended up going down several hundred feet, the water reached all EPA regulations. So it was able to actually be discharged directly directly into a river system. So that just tells you about the importance of the rocks and the reeds and all the little microorganisms that are actually living inside of the system. We've created our own version of this. Again, replicating nature is my favorite thing to do. Here's a beautiful feature down in South Florida. Actually, the reason I put this picture in is the area that we're working in Southern Africa is very similar to northern Florida. It's a Zone 9 water feature. Warm temperatures, it's basically very tropical, but they can get ice and they can get freezing. And actually, we did this during our TV show Pond Stars many years ago now, but still, this is one of my favorite features because it just has all those different elements that I feel are very important from a water feature design. But the thing that we're talking about specifically today is water quality. Our goal with a wetland filter and with all of our water features is to recreate what's known as an oligotrophic ecosystem. I'm a root word person. Oligos, if we split that off, it means little or few, a small amount of food inside of the aquatic ecosystem. This is actually Lake Tahoe, located right here in the United States. You can see from the picture, very, very clear water. This is, I don't even know how deep that water is. It's probably 20 to 30 feet deep. You can see the bottom. When there's not a lot of food in the water, you're not going to have a lot of algae, and specifically, you're not going to have a lot of phytoplankton. So phytoplankton is basically small algal communities. They're microscopic. Sometimes you can see them visibly with your eye. So these are tiny little plants, basically, photosynthetic organisms that are floating around in the water, and they're utilizing nutrients from the water as well as the sunlight, and it creates actually a cloudy water system. So you can see the water is very clear here because as soon as you eliminate the nutrients, there's not enough food. Nothing is actually going to grow. You're not going to have those algal blooms. From a biomimicry standpoint, I want to figure out how I could remove food from the water. And that food basically is fish waste. Now in our backyard ecosystems, we kind of throw a wrench in that equation because we're actually feeding our fish. So as soon as we start taking food and adding it into the ecosystem, we've bypassed Mother Nature. Mother Nature is not supplying that naturally. We are taking a high protein food and adding it into the water. So now all of a sudden the fish are going to feed on that, and their waste product could actually become toxic, which is what we want to eliminate. In nature, how does water get filtered? Basically through wetland filtration systems. So it's a riparian zone where we have aquatic vegetation and marshlands and things like that. They're going to utilize all the nutrients in the water, and the water gets brought to them through wave action. It could be in a riverine type of a system where you actually have flowing water going through it, but there needs to be some sort of a mechanism to move the water into the wetland area, and then it slowly flushes its way out. By replicating that, we're going to actually use a pumping system, and we're going to discharge that nutrient-rich water down into the root zone at the bottom of that wetland area. Then the water flows up through the aquatic vegetation. They've actually done many, many studies on them where actually they could remove toxic chemicals, heavy metals, as well as other types of even nuclear radiation. So these wetland plants are just unbelievable, and we're just barely scratching the surface on understanding how they actually operate. So there's still a lot of studies that are being done. All right, we're putting in the water distribution system for the wetland filter. This is one of the most important parts because it all comes down to water velocity changes. What we have here is we have specific openings. We have 231 square inches of open space. That's going to allow a specific water flow coming out per second. So what we have, it's modular. We can cut this in sections and we can add and subtract them according to the project needs. The other nice thing about this is these connect to the end of the Snorkel, which is actually a clean out system. The whole idea is we have high velocity water coming in. That little guy right there, 3-inch connection. High velocity water comes in, 93% reduction in water velocity inside. The big sediments, if you look down here at this end, big sediments are going to build up down here in this channel, and then you have these open slots over here on the sides. That allows the water to actually come on out. The water's then going to come up to the layer of AquaBlox. Now the AquaBlox are going to go across the entire bottom of the feature. The way this is going to work is it should take approximately 9 to 10 minutes for for the water to actually flow through the AquaBlox layer. That's going to allow the sedimentation process to actually occur, which is very, very important because wetland filtration, the biological organisms, the microorganisms that are living inside, the nitrifiers, they are very, very particular. And if you get a lot of sediments building up, they're not going to actually function properly. So we want to drop all the sediments out as quickly as possible, and then we could actually have clear water flowing up through everything. In our wetland filtration system, there are multiple layers of filtration, and it all starts out with the Snorkel Centipede system on the bottom. I discussed that earlier about the water velocity coming in. We have a 93% reduction in that water velocity to allow the large sediments to accumulate. The next layer is the small AquaBlox. This is a modular system. It's exactly like the large AquaBlox that we used in the 50,000 gallon reservoir down at the bottom of the feature. This is a smaller version. The only reason we need the smaller one is because it just has to spread the water out in all directions. So we're getting three-dimensional water flow, which is critical. So we need to have that water evenly flow out along the entire bottom so we have nice water distribution going up through the filter media. The key to this is down at the bottom, we have our negative edge, which is dropping water into the reservoir. It oxygenates the water. So that means the water that goes into our pump is saturated with dissolved oxygen. That is important because the biomedia, the gravel bed on top of this, is going to be loaded with different types of microorganisms, and they're aerobic just like us. The more they eat, the more they need to breathe. We want to feed them a nutrient-rich solution, but it has an abundance of dissolved oxygen that allows them to complete the nitrification cycle. The other thing that actually is happening inside of here, you see these AquaBlox panels that we utilize for creating the actual blocks themselves. They come in flat panels. We could assemble them on site. But if you look at them, they're not actually perfectly smooth. They have these little fins on them. So when the water flows up through them in all directions, we get mixing of the water. We have little micro eddies that are actually occurring inside. So this is important. We're breaking down the laminar flow. So if this was just a big hollow space underneath the entire filter, it would function. It wouldn't function as well though. So by mixing the water as it flows through all these little panels, we're speeding up the precipitation process. So all the really, really fine sediments are going to drop out of suspension down on the bottom. That's going to keep the nitrifiers actually happy. They are very, very picky. So the more sediments that we could remove from the system, the more effective the actual filtration will actually become. So it's multiple layers. The first piece distributes the water at the higher velocity. The second layer is this. This is actually going to create a hollow chamber underneath. So when we go to clean it, we back flush everything through our Snorkel system. These lines connect all the way through everything, and it's at the deepest location. So when we put a pump down at the bottom of the Snorkel, it will effectively draw all the sediments that are going to be laden throughout the entire filter bed. They're going to get removed. The nice thing about that is all of that water is not going to go to waste, especially in a dry area like this. We're going to take that nutrient-rich water with all the little dissolved organics and the broken down stuff. We're going to pump it into the surrounding gardens. That's going to be an incredible boost of nitrogen as well as all types of macro and micro nutrients that these actual plants are going to utilize. Riverbeds are very, very effective. Wetlands are unbelievable. The amount of biodiversity that's actually living inside of this is going to be incredible. planted up with a variety of different types of aquatic plants, cattails, sedges, grasses, rushes. Some of them are going to be native, some are going to be tropical style plants. Biodiversity is key. You don't want to have a monoculture, one type of plant through the entire system. But if there's one little glitch or if there's one problem and that plant starts to suffer, then all of a sudden the entire system becomes compromised. Nature does not actually create monocultures. Nature is going to have a diversity of different types of plants that'll grow symbiotically together. Here's some of those different root systems that I was talking about. So you can see different types of rushes and things are going to have root systems that go very, very deep. Others are going to go in a wide kind of a mat type of a setup, which is actually like cattails, very shallow, but it's going to spread out in that top layer and go all over the place. And actually, I don't use these too much because they can be a little bit too aggressive and it will outcompete things. But again, this is just for demonstration purposes. For each one of these centipedes, right there, we have 16 small AquaBlox. We have 8 on this side, we have 8 on that side. So once I know the requirements of the project, I could add more pieces as necessary. I want to have approximately 100 gallons per hour of flow. So 100 GPH, so that means I need 1,600 gallons per hour of flow for one of these sections. So once I know that, I could easily do the math and I could add up for the desired water flow rate for that filtering system. We have different levels for different size rock and gravel. I have 8-inch sections. For Africa, I want a little thicker. I want 10 inches and I will actually show you that. So actually, here's what I did for this particular project. So I did 10-inch layers. So by going with a thicker gravel layer, it's actually going to give me a little bit more filtration. So the filtration is basically coming from all of this rock and gravel. And that's because that's the home to all the microorganisms. So therefore, the more rock and gravel we have, the more space we have for more microorganisms. So we can increase this significantly. 3 10-inch layers, I have 30 inches of river rock, and then I also have my 9.5 inches for my AquaBlox down here in the bottom. The subsoil was terrible. I mean, it was bedrock. It was chunks of rock and gravel, and it was, you could rake it forever, and you're never going to remove all the rocks and pieces out of the soil. So what we ended up doing is we came over the subsoil. So we did our excavation, we overdug it a little bit more, 3 to 4 inches more than we needed. Then we came in with a layer of river sand on the bottom to create a bedding layer. Then on top of that, what I did was I came in, I don't know if you could even see it in this drawing, but there's a layer of concrete cloth inside of here. The reason I did that was because of the rocky subsoil, but I was also a little bit concerned with burrowing animals. They have mongooses and they have aardvarks and things like that that are big, powerful diggers. So I want to make sure none of these animals are going to be able to dig through the outside perimeter and damage the rubber membrane. So the rubber membrane is critical. So that's the basis for our system because it's holding all the water in place. So I want to do any means necessary to make sure that that layer is not compromised in any way, shape, or form. So a layer of sand, the concrete cloth, and then I come on top of that with our geotextile layers, and then I sandwich our rubber liner in between. Once I have that infrastructure in place, I could then start assembling all the different pieces that we have. I have 5 different layers of our centipedes and snorkels going through. Each one of these is set at 9 feet center. The reason we did that is because it lays out perfectly with all of our AquaBlox. All the AquaBlox line themselves up and everything actually works out perfectly. Now, once we have our wetland filters operational, you could see from the results, very, very versatile in a variety of capacities. It allows us a ton of design flexibility, all these different projects, recreational ponds, ecosystem ponds, fish ponds. We can come up with the right filtration system that's going to manage the waste inside of the system. Huge stormwater management systems. This is actually a lead facility outside of Pittsburgh, Pennsylvania, which I've talked about before. Absolutely spectacular, taking all the water off of the roof of this giant building over here. Stormwater management, etc. This is one of the greenest buildings in the world when it was completed now 10 years ago. Larger recreational ponds. The possibilities are truly endless. Every water feature, every water treatment plant in the world actually uses biological filtration at some point as part of their water treatment processes. It's the only way to actually manage excess nutrients. And right now, due to expansion in our communities going all over the world, increasing the filtration systems on these water treatment plants is critical. This is why whenever I'm designing something, I try to design it for the future. I don't want to design the bare minimum that's going to work with a brand new system. I want to give it the capacity so that they could actually grow over time, and the water quality is going to be consistent no matter how many animals keep replicating it. The growth periods are going to keep going inside of the system. We're going to have the capacity to actually handle all that stuff. Couldn't be happier with this outcome. Everything is really coming together. We have not compromised on our design initiative of creating a series of rocky ridges that are kind of bypassing and cutting their way through the entire property. And it always just blows me away every time we can get the water operational, because it really brings everything to life. Just to see, we've been setting those water levels very specifically. The flow rates going up through the AquaBlox and going through the River Rock system is critical, but every time I turn it on, I'm blown away by it, because it's just, everything comes to life. You could hear it, you could feel it, you could see the water and how it's going to interact with the surrounding environment. So bringing the teams of people in from around the world is a joy to have everybody there. And the only way we could really pull this off is working with our certified contractors, where we all understand the specific roles. And that's where it really comes into play, and it all makes sense for us because we have a set process for everything we do. So once we understand the design parameters, we could easily tackle any single type of project out there, and the results are speaking for themselves. Bringing everything to life is just so fulfilling at the very end, and then it also is setting the stage for our upcoming projects. We have multiple pumps we still need to get operational. We're going to talk about the final design layers, the external hardscapes, the little details on the landscaping, and then the amazing cenote, which is going to be second to none. I cannot wait for that component to be finished, because it's going to be something the world has never seen.